Okay, let's talk about the OSI model and also data encryption in the TCP/IP model. First thing we're going to start off with is the OSI model. And it consists of 7 layers. Layer 7 is the application layer. Layer 6 presentation layer. Layer 5 session layer. Layer 4 transport layer. Layer 3 is network layer. Layer 2 is data link, and layer 1 is physical. These are the 7 layers of the OSI model, and what the OSI model basically is it's a group of rules that actually dictates how information is transferred through the internet, whether it be web browser, email, anything traveling through the internet actually uses this model, and that's why everything is standard. You can be in any country, any classroom, any state, and you'll see all the web pages all the same. And we have 7 layers here, and there's a couple ways you can remember it. You can either go, all people seem to need data processing, or please do not throw sausage pizza away. It just depends on what direction you want to go. So let me repeat that. All people seem to need data processing from 7 to 1, or please do not throw sausage pizza away. That's how you can remember it. And believe it or not, that is an industry standard, those 2 phrases you have. They're just not made up. Everybody uses them, so that's what's happening here. Now, if we take a look at the model, we'll begin on the physical layer. On the physical layer, that's going to consist of the 1s and 0s, the electricity, the power, your cable, and your basic hubs. On layer 2, on the data link, that will be your switches, and here is where you have your collision domains that exist. Now, to have a basic network of just computers hooked together with no internet connection, you need these 2 layers to do that. So if you have a question that is just on basic networking, it's going to be these 2 layers. Layer 3 is where we get into the internet, and here's where we use routers. Switches and routers. What the routers use are IP addresses, and the switches use are the MAC address. That's how they're able to determine the traffic. And remember, to get onto the internet, you have to have an IP address, and that's where this layer comes into play. Then layer 4 is called the transport layer, and it's exactly what it means. It helps transport the information, quality of service, how big windows you can have, and that kind of thing. The last 3 layers, we have session, presentation, and application. These 3 are computer side, which means they're on your computer before it goes to the internet. So if you have a question related to your computer and your connection, it's typically going to be these 3. What the session layer does is it does the check to see how fast you can connect, and all the details of if you get disconnected, you get the message back on it. Presentation layer is the one that will take whatever file you're using, say you're using a Microsoft doc file, and it will break it down, and when it comes back up, the presentation layer puts it back into a doc file, and the way I remember it, it's going to present it to be used by the application layer. So that's how you can remember what this one does. And the application layer, of course, is going to be your email program, your web program, FTP program, anything of that nature. And a question that is out there, what layer does not have its own protocol? Layer 7. That is a question you see all the time. And the reason why is because layer 7 is what calls a protocol. When you do email, it calls the email protocol. When you do web page, it does the web page. So if you ever get a question that says what layer does not have its own protocol, it's layer 7. Everybody else has a protocol on there. And so that's pretty much the basis of the OSI model. The next thing I'll cover will be the data encryption. And what that means is when it goes up, how is it converted into different formats? So the bottom, remember what I mentioned earlier about the physical? It's going to be bits. On the next one, layer 2, was be frames. Layer 3 is packets. Layer 4 is segments. And the top three, because they're all related to your computer, this is odd data. So if you ever get a question that says, what layer would you find segments on? Layer 4. If you get a question, what layer would you find frames on? Layer 2. Now, the hardest thing I had when I was doing this was, how do you remember this particular sequence? The easiest way to do it is, it's alphabetical, and then the top is data. So if these are all shuffled, remember bits, frame, packets, segments, data. Just remember it's going to be alphabetical from the bottom to the top, and the last one's data. So that's the easiest way to remember it. If you don't do that, you have a problem of, do packets come before frames, frame before packets, alphabetical, data. Easiest way to remember it. And the final thing we'll cover will be the TCP IP model. And on that one, the top three layers, they combine them together because remember, this is all computer related. So they just named the top layer here application. They kept transport the same because that's basically generic. And then on layer 3, remember how I mentioned this is how you get onto the internet? So that's the reason why this layer is called internet. And then what they did is, remember how I mentioned that these two layers you need to create a basic network. So on the TCP/IP model, they called these two network access. All they did is basically kind of mention what I told you, what they do separately, and they just combined them. Top three layers are computer related, so they just named it an application. Transport remains the same. Remember on layer 3 is where you get your routers, you get onto the internet, so they just named it internet. And then remember how I mentioned at the bottom two layers you have to have a network. So they just named them, it's going to be network access. Easy way to remember it, and if you keep it in this particular lineup, it's easy to go. And that's the basis of the OSI model, of data encryption, and of the TCP/IP model. Thank you.